I've got a little SL question here. It's come from my daily questions, and if you have a read of it, we've got two functions and they intersect twice. Find the values of k. So I've got a quadratic and a straight line, and if they intersect twice, basically that means that you've got whatever this quadratic is, it comes around like that, and you've got a straight line that goes through it in two distinct places. So we've got two solutions. So what I'm going to do is I'm going to start off by making the two things equal. And what I've just said, there's two solutions. So if I make it equal to 0, if I make this equation equal to 0, which is kx squared plus x lots of, and now we've got k minus 2 here, minus 1 equal to 0. Sorry, I beg your pardon, that's minus 1 there, isn't it? From that, it's plus 1. So now I've got this, because it intersects twice, I've got two solutions. I know my discriminant is b squared minus 4ac. The discriminant is greater than 0. So I'm now going to put the b into here, so I get k minus 2 squared minus 4ac, so it's minus 4k, is greater than 0, because c is 1 and a is k. Now if I expand that bracket, I get k squared minus 4k minus 4k. So why don't I just change this? It's 4k from inside the bracket. And I've also got another minus 4k here, so it's minus 8k plus 4 is greater than 0. Now I'm going to solve k squared minus 8k plus 4 equal to 0 on my calculator. It's not a non-GDC question. I can use my calculator and I want to solve that equation, and I want to get two distinct values. So 1 minus 8 and 4, and I solve it and I get k equals to 7.46 and 0.54 ish. Now these two are both up here, so it's and here, so it's either this one, or this one. It's not equal to, because I actually want the values. I've got the greater than, even though I use the equal to solve. I have to decide which of these three it's going to be, and to do that I'm going to use a number line and do a sign test. So I'm going to get my number line like this, and on my number line I'm going to write down the critical values. So this is 7.46 and 0.54. And I'm going to put three different values in to this equation. This is very important because this was the inequality that I had. Sorry. And I'm going to put in one from here, so less than 0.54. So I'm going to put 0 in. When I put 0 in, I get 0, take away 0, plus 4. This will work. When I put 1 in, it's going to give me 1, take away 8, plus 4, and that is less than 0, not greater than 0. So all these values won't work. So 1 in goes 1 squared minus 8, give me minus 7 plus 4 minus 3, which is not greater than 0. It doesn't work. And let's choose 8. So I've got 8 squared minus 8 times 8, so that's 0 plus 4. This one does work. So I want anything greater than 7.46 and anything less than the 0.536 or 0.54. So that's how to solve that question. There's a lot going on. It's probably a 6 or 7 point question.